Welcome to the students of 6th semester mechanical engineering. In this session, we are going to discuss the NC coordinate systems, that is numerically controlled machine tools coordinate systems, difference between NC machines and CNC machines. Then we will also see the DNC machines, direct numerical controlled computer controlled machine tools, and distributed numerical control. We will see one by one. Coordinate systems. What are coordinate systems and why it is necessary in NC machines? That we will see now. Basically, there are three axes in a three-dimensional Cartesian coordinate systems, and they are X, Y, and Z axis. You need to understand which one is X axis, which one is Y axis, which one is Z axis. And without the knowledge of these three axes, it is difficult to write the programs and also difficult to understand the written programs. Apart from those three axes, there are also rotational axes. That is rotation about each of these axes, which is specified as A, B, and C. So rotation about the earlier mentioned three axes is specified as A, B, and C. So we will see the axis with the help of this diagram. So there is a machine tool and table arrangement here. The Z axis is shown here. Normally, the Z axis is the axis of rotation of the spindle. Here there is a spindle. The axis of rotation of this is Z axis. Generally, the movement of the tool towards the workpiece, which is kept on the table, is negative, and movement of the tool away from the workpiece is positive. That we will see when we come to sign convention. Then X axis, it is related to the movement of the table. Rightward movement is positive and leftward movement is negative. Once you fix these Z axis and X axis, Y axis will be perpendicular to both these two axes. That we will see now. If it is a turning machine, that is a lathe machine, there are two axes you can see. Here, the axis of rotation is horizontal. Therefore, Z axis is horizontal. Z is negative when you move towards this headstock, and it is positive when you move away from the headstock. And X axis is related to the diameter word. It is related to the diameter in case of turning machine. Any movement away from the workpiece is positive. This is positive. And any movement of the tool towards the workpiece is negative, which we will see here. So we have shown both milling as well as lathe machine to understand X, Y, and Z axis. In case of milling machine, the Z axis is vertical, as you can see here. Z axis is vertical because the axis of rotation of this spindle is vertical. And X axis, which is perpendicular to Z axis, related to the movement of the table. It is positive here in this direction. Then Y axis is perpendicular to both X and Z axis. So in milling, you have three axes, X, Y, and Z. For turning machines like lathe machines, there are only two axes, X and Z. You can see Z here. Z axis is horizontal in the case of lathe machines, and X axis is perpendicular to Z axis. What is X axis? It is related to the diameter of the workpiece. This is the workpiece. So this one is the workpiece. X axis is related to the diameter of this. Now we will see the definitions or convention, axis convention. It is just like naming the axis. So convention, what is the convention for Z axis? In a CNC system or NC system, the axis of rotation of the main spindle decides the Z axis. Suppose you have more than one spindle, then one of the spindle is considered as the main spindle to fix the Z axis. Then along the Z axis, the direction of increasing the distance between the tool and workpiece is considered positive. What is x-axis? The x-axis is horizontal and it is parallel to the work holding surface. The x-axis is positive in the direction to the right when viewed from the spindle towards the workpiece, like in the case of milling and turning. Then y-axis. X, Y, Z axis are mutually perpendicular. That is, if you know X axis and Z axis, Y axis can be easily fixed. Once the direction of X and Z axis are determined, the Y axis orientation can easily be fixed. So this is regarding the axis convention. Then what about the rotational axis? The rotary axis A, B, C are around the X, Y and Z axis respectively. They are considered positive for clockwise rotation when viewed in the positive side of these linear axes. In other words, the positive direction corresponds to the direction in which a right-handed screw advances along the particular positive axis. Now, these are the conventions for the coordinate systems, which is nothing but X, Y, Z axis and rotation axis A, B and C. So more about this will be discussed when we discuss the programming part in the CNC machines. That is, when we discuss the programming examples, we will discuss once again these coordinate systems. Now, what is a CNC system? We have discussed already NC system. What is a CNC? It is a computer numerical control system. It is an NC system which utilizes a dedicated stored program computer to perform all the basic numerical control functions. So in CNC system, we are using a dedicated device known as computer. The NC systems, they use the conventional hardwired controllers for the interpretation of the codes written in the program and to convert the written instructions into necessary machine instructions to manufacture the part. So the NCs will make use of hardwired controllers. In CNC system, these hardwired controllers are replaced by a computer. The computer will perform all the functions of NC system. In a CNC system, one computer is used as the central control unit for one machine. So now we will understand what are the differences between NC machines and CNC machines. NC, as we have already studied, numerically controlled machine tools. CNC is computer numerically controlled machine tools. So controlling the machine tool with the help of numbers and alphabets. How it takes place in NC? It is hardware controller is used, which is not flexible. Whereas in CNC, the microprocessor, that is computer, is used. That means the control is very flexible. Then, with respect to part programming errors, the errors are common as programs are stored in the tapes. We are using punched tapes in NC machines. So errors will be very common. Whereas in a CNC machine, errors are easily corrected without repeating the entire work. Then in NC machine, it is difficult to achieve the optimum speed and feed. The speed changes during the process is not possible. Whereas it is possible to change the speed and feed during the machining process in case of CNC machine. You can change the speed and feed. Then when it comes to storing of the programs, the NC machines are used and the programs are stored in punched cards, which is difficult to store and they are prone to errors. There is a possibility of errors. Whereas in CNC machine, the programs are stored in magnetic disks. They are used for storing and modifying it, which is easily done. So storing the programs and modifying the programs is easily done in CNC systems. Coming to the input devices, the NC machines will usually use the tape reader, which is unreliable. Whereas in CNC machine, the floppy disk and the hard disk drives earlier were used, which are reliable. Then management of information. In NC machines, it does not store the management information. Whereas in CNC machine, they do management functions, that is the process plans, scheduling, master scheduling, etc. can be done. So almost CNC has replaced NC nowadays because the CNC is very flexible. You can change the programs at any time. That flexibility is not there in NC machines. Then apart from flexibility, The CNCs are very accurate. You can expect the accuracy in microns very easily in CNC machines. So CNCs have replaced the NC machines. NC machines are very old machines. Then what about the control system in CNC? We have seen the control system in NC. What about CNC control systems? So CNC, there is an input device. It can be a tape reader or a floppy disk, etc. Then there is computer. The functions of traditional hardwired controller are done by the softwares in the computer. Then there is a hardware interface. Without the hardware interface, there is no possibility of machining. It is equally important to have a proper hardware interface. It is between the machine and computer. Interface is always, suppose this you consider it as computer, this is the machine tool. So interfacing is necessary. So these are the basic CNC control systems: input, computer, and hardware interfaces. Of course, there is machine tool which performs the actual machining operation. So the machine tool will receive all the instructions from the computer. There is also a feedback channel. So this is the CNC control system. What are the functions of CNC system? The functions of CNC system are difficult to achieve in the normal NC system. They are machine tool control, in-process compensation, improved programming and operating features, and there is also diagnostics. All these things we will discuss in the later hardware chapters. Now we will study another important machine that is called as DNC. DNC stands for direct numerical control. So you can see here there is a central computer and large memory called as bulk memory. So in this bulk memory, there are programs that are stored. NC part programs are stored in this bulk memory, and central computer is there. There is one central computer. Here it controls more number of machine tools. The communication to these machine tools is with the help of a telecommunication line. So with the help of central computer and part programs, you can control more number of machine tools. That is direct numerical control. So let us see. So number of machines are controlled in DNC. All this controlling takes place in real time. So DNC refers to control of number of machine tools by a central computer. So there are part programs stored in the central computer, then sent to the machine tools on demand. So whichever machine tool requires the program, only that program will be sent to the required machine tool. Then there is a transfer of data. This is important. Without transfer of data, there is no machining activity taking place. So transfer of data takes place through the telecommunication lines. So we have shown communication lines here. This is the telecommunication line. So transfer of data takes place in real time. Then there is another important machine tool that is called distributed DNC. So in distributed DNC, we have a satellite computer. Apart from central computer, we have a satellite computer and memory buffer, central satellite computer memory buffer like this, which handles a small group of machines here. So what is distributed DNC? When number of machines to be handled is very large, the central computer is connected to the satellite computer. Each of these satellite computers will serve a group of machines. Data to the machines also are routed through these satellite computers. Now, why DNC is used? So following are the functions of DNC. So DNC, you can call it as a NC machine without the punched tape. No punched tape is used. And NC part programs are stored. That storage capacity is there in DNC. Then data collection, processing and reporting is there. Then communication, which takes place in real time. So these are some of the functions of DNC. So it is a NC without the punched tape, because in punched tape there are a lot of difficulties. It is difficult to prepare the tape and also difficult to store the programs in the tape. So almost the punched tape is obsolete. It is replaced by programs which are stored in the memory of a central computer. Again, part program storage. It is made available to individual machines whenever it is required. So part programs are made available to the machines whenever it is required. Another interesting feature known as provision to add the new programs. Suppose you have written a new program, you can add the new program and delete the old programs, and you can also edit the existing programs. So it is providing you a lot of flexibility. DNC softwares, they must accomplish the processing function. So it is equally important to process the data and programs. The data storage subsystems must be structured to perform certain processing and management functions also, such as file security, file backup, and display of the programs. Then functions of DNC, continuing with that, data collection, processing, and reporting. So the previous two functions, that is the transfer of data from computer to the machine tool. It is the reverse function where data is transferred from machine tool to the computer. The purpose of getting the feedback data from the machine tools is to monitor the production process. So it is almost a foolproof system. DNC is a foolproof system. Data are collected on production piece counts, tool usage, machine utilization, and other parameters related to the production. Then communication is important, that is transferring the programs to the machine tools. So there is a direct communication link between the following elements. What are the elements? Central computer to the machine tools, central computer to the part programming stations, then central computer to the memory which stores the NC programs. The communication system can be extended to include even the CAD systems, remote diagnostics, shop floor control, etc. Other computer automated systems in the plant. So these are the communications. So it obviously DNC is having a lot of advantages: elimination of punch card and tape readers, greater computational capacity and flexibility, easy to store the programs in central computers. Programs are stored in CFILE, that is cutter path file. They can be sent to any required machine. So reporting the shop performance. So that is the data is received back from machine tool, which gives information regarding the performance on the shop floor. Establishment of framework for further automation. This is also possible in DNC. So we have discussed in today's session, we have discussed these things. That is, we have discussed the NC coordinate systems, difference between NC machines and CNC machines, and an introduction to DNC machines. This is what we have discussed. So next we will continue in the next session the structure of CNC machines.